this video, we'll go over the process of naming an acid given the formula and writing the formula for an acid given the name. We'll start with the process of naming an acid given its formula. Acids have their own unique system of naming, which is different than that of other compounds. Once you are familiar with the system of naming acids given their formulas, it will be fairly easy for you to determine the formula of an acid given the name. Acids can be divided into two main categories: binary acids and acids containing a polyatomic ion. Some textbooks call these ternary acids or oxyacids. We'll just call them acids containing a polyatomic ion. Binary acids are made up of only two elements. One is hydrogen and the other is a nonmetal. The second type contains more than two elements. Hydrogen is one, and the polyatomic ion contains two or more elements. Remember, a list of polyatomic ions and their names is supplied in the Science 10 data booklet. We'll start with the system for naming binary acids. A binary acid is made up of hydrogen and one of the nonmetals. As shown here, nonmetals are the elements to the right of the staircase in the periodic table. A binary acid is named as follows. After we've identified the acid as containing only two elements, or a binary acid, we start by writing the prefix hydro. Next, we write the root of the nonmetal name. Lastly, we add the suffix ic or ic to the root of the nonmetal name and follow it with the word acid. Let's do an example. Name the acid HF. HF has only two elements, so it's binary. Therefore, we can use the system for naming binary acids. So we start by writing the prefix hydro. Next, we add the root of the nonmetal name. The nonmetal name is fluorine, so the root of the name is fluor, F-L-U-O-R. Notice that in the name of fluorine, the U comes before the O. Lastly, we add the ending ic, acid. So to summarize, the name of this acid is hydrofluoric acid. Let's do another example. Name the acid H2S. H2S has only two elements, so it's a binary acid. Therefore, we use the system for naming binary acids. We start with the prefix hydro. The nonmetal is sulfur. For the root of the nonmetal name of sulfur, we simply use sulfur. We finish it off by adding ic, acid. So the name of the acid H2S is hydrosulfuric acid. An acid with a polyatomic ion, or PAI, is named as follows. If the name of the polyatomic ion ends in ate, replace ate with ic and add the word acid. If the name of the polyatomic ion ends in ite, replace ite with us and add the word acid. We can summarize how to name acids with polyatomic ions with this. Ate goes to ic acid and ite goes to us acid. Let's do a few examples. We're asked to name the acid with the formula HClO4. Acids are all ionic, so we can break up HClO4 into H+ and ClO4- ions. We see that the polyatomic ion ClO4- is called perchlorate, which ends in the letters ATE. The rule for an acid with a polyatomic ion ending in ate is replace the ate with ic and add the word acid. So this acid is called perchloric acid. So we can summarize by saying the name of the acid HClO4 is perchloric acid. Let's do another example. We're asked to name the acid with the formula HClO. Acids are all ionic, so we can break up HClO into H+ and ClO-. The polyatomic ion ClO- is called hypochlorite, which ends in the letters ITE. The rule for acids with polyatomic ions that end in ITE is replace the ITE with OUS and add the word acid. So hypochlorite becomes hypochlorous acid. So to summarize, the name of this acid is hypochlorous acid. We can also use the rules for naming acids to go backward and write the formula for an acid given the name. We'll use a couple of examples to outline the process of writing the formula for an acid. The first example is, write the formula for hydroiodic acid. The first step is to decide whether the acid is binary or whether it contains a polyatomic ion. Hydroiodic acid starts with hydro, so we know that it's a binary acid. If it's a binary acid, the first step is to locate the nonmetal and find its charge on its anion. The root IOD corresponds to the nonmetal iodine. Locating iodine on the periodic table, we see that the anion of iodine has a charge of -1, and it's called the iodide ion, I-. The next step in the process of writing the formula is to add the number of H's that are required to balance the charge on the anion. Because the charge on the iodide ion is -1, it requires one H+ ion to balance the charge. So we have one H+ ion and one I- ion. These combine to give the formula HI. So the formula for hydroiodic acid is HI. So to summarize, if it's a binary acid, find the nonmetal and its charge on the periodic table. Then determine the required number of H+ ions to balance this charge, and use these to complete the formula. Let's do another example. Write the formula for nitrous acid. There is no prefix hydro, and the name ends in OUS. So this is the type of an acid with a polyatomic ion. So now that we've identified this as an acid with a polyatomic ion, we must use the correct system for naming it. If it's an ic acid, find the polyatomic ion ending in 8. If it's an us acid, we find the polyatomic ion ending in ite. Nitrous acid ends in OUS, so we find a polyatomic ion similar to nitrous, but ending in the letters ITE. Looking on the table of ions, we find nitrite with the formula NO2-. The last step in writing the formula for an acid with a polyatomic ion is to add the number of hydrogens needed to balance the negative charge on the polyatomic ion, and use that to complete the formula. The nitrite ion, NO2-, has a charge of -1, so it requires one H+ ion to balance the charge. So we have one H+ ion with one NO2- ion. These two combine to give us the formula HNO2. So to summarize, the formula for nitrous acid is just HNO2. So to summarize the whole process, if it's an acid with a polyatomic ion, look at the ending on its name. If it ends in IC, find a polyatomic ion with a similar name ending in 8. If it ends in OUS, find a polyatomic ion with a similar name ending in ite. Finally, add the number of hydrogens required to balance the negative charge on the polyatomic ion to create the final formula. Here's a flowchart for writing the formula for any acid given its name. You may want to pause the video and make a screen capture of this so that you can print it out. We just want to point out that this little table is included in the Science 10 data booklet. It has the names and formulas for 4 common acids you'll be dealing with in Science 10. Don't forget to refer to this if you need to. Note that the formula for acetic acid can also be written as CH3COOH. This formula is frequently used for acetic acid.